So we started the closure on that day, and we will work on that closures now, because closures is a big topic. It may take 3-4 days to complete. So let me, 1 second, let me close all this one. Okay, so let's do the closures. I will start the new folder. New file 1.html. So we have seen on that day two things. One is the scope chain and one is the lexical scope. I will go shortly with both of them so that you can refresh your memory. So one of the scope chain is something when I am here inside script tag, I am in the global scope. I am in the global scope. So anything which I create here, any variable which I create here is in the global space. So for example, if I say var a equal to 1, and then I say function f, and in the function f, if I write something like this, var b equal to 1 and return a, and if I run this function, so it will output 1 because a is equal to 1. But when I do like this b, console.log of b, then it will give the, it will give me the error that b is not there, b is not defined, and so I will get the error because b is created in the scope of this function. So I cannot access that b outside the function because this is locally applied to this function, will not be available to the global scope. Whatever I create in the global scope will be available inside the function, but whatever I create inside the function will not be available in the global scope. So this is called a scope chain. Let's go to the another topic which we did is called the lexical scope. Lexical scope means wherever the code sits. So lexical scope is where physically the code or function or variable sits. So if I create a function, for example, f1, and I say var a equal to 1, and then I call the f2 function, and I create another function called as f2, and here I'll say return a. So a is created here. Many people expect that since a is created here, I can access the a variable inside the f2. But it is not like that because f2 is created in the global space. So the lexical scope of the f2 is the global space, not the f1. So since the f2 is in the global space, it can access only the global variables, not the variable created inside the f1, which is local to the f1. So when you are invoking the function, that has nothing to do with the real problem. So real thing is that code should be physically sit in that function or in that scope. Here, the physical position of the f2 is in the global space. So the lexical scope of f2 is global, but the lexical scope of f1 is also global. But when I go inside the f1 and I call f2, I cannot access the variable a equal to 1 because a equal to 1 is created lexically inside the f1. So f2 cannot access anything which is created inside the f1. So that is called the lexical scope. Lexical scope is something you have to see where exactly is the function created, where exactly is the function located? Whether it is located in the global space or it is located inside the local space. So here, if I run F1, let's run F1. And we'll see in the console.log. So we get error, A is not defined. Why we are getting error, A is not defined? The reason is A is defined inside the local space of the F1, whereas we are calling F2, which is in the global space, and here it is returning A. So many people will expect that, oh, A is equal to 1, it should be accessible in the F2, but that is not true. Since F2 is created in the global space, so we won't be able to access A from the global space. So now you tell me what will happen if I do like this. Var A equal to 5. What will be the value of this A? What will be the value of this A? It will be 5. Now whether it will give error or not. Previously it was giving error. No. The reason is it will not give error because we created a variable A in the global space. Is now created in the global space, so F2 can access that variable from the global space. So this is how we work with the lexical scope. Lexical scope is very important question for the interview, and you have to answer it like that. Lexical scope is the scope where the code physically sits. So wherever it sits, if it is sitting in the global space, that means lexical scope is global. Whenever the variable is sitting in the local function, then the scope is locally to that function. So that is called the lexical scope. Now we will go and do little bit of understanding of the closures. Before we write a code of the closure, we will try to see what exactly is the closures are. So let me open the new page, or I will go here. So this is the page. Let me see what I can do. Okay, let's take this one. Okay. Now let's say, okay, I'm not able to. Okay. Can you see this circle? Yes. Okay. So now let's say if this circle is the global space in the JavaScript. This circle is the global space in the JavaScript, and it has few variables or function. So let me say, let us say this is a variable, this is another variable, this is another variable, and this is function. So this is the global space. This whole round is a global space, and we have these variables 1, 2, 3. Let's say this is called A1, this is called A2, this is called A3, and this is called function F. So all are sitting in the global space. Okay. Now let me create another one, which is a very small one. Again, this is the global space. I created another function. This is called F function, and this is a variable called as A. So everything is sitting inside the global space. Now let's see this in the function f. In the function f, we have another function. So I am actually writing it here, but it is exactly inside this function. So this is a global space, this is a function, and inside this function, I have another function here called as n. And inside this I have the variable called as c. And inside this function, I have the variable called as b. So let me draw it. Sorry, let me draw it little big so that I can explain you properly. Okay, let's take a bigger circle. This is my global space. This is my function f. Inside the function I have another function n. And now I will mark it with and here I have the variable a. This is function f. This small round shape is called as function n, and I have a variable here as a b, and I have another variable here as a c. So now tell me, whether function f can access this variable a, yes or no? Yes. So this function f can access the variable a, and this function also can access variable b because b is created inside this function scope. And this is the n function. Whether n function can access variable a, yes or no? Yes. Whether n function can access the variable b, yes. And n function can also access c because c is created inside the n function. Okay. So now another question is whether in the global space can I access the function n? No. Right. So this is how the scope chain works. Now let's talk about the closures. Now what I will do, let me create another similar diagram. So remember this diagram because I will refer to this diagram when I will draw new diagram. So just remember this diagram. We have the global space function f, we have the b, we have n function, and we have c variable. So just remember this function. And now I will delete whole and I'll create again. This is my global space. This is my function f. This is b variable. This is a variable, and this is the function f. Now somehow I move this n function from the f function and I move that function to the global scope. So I move this n function here. This is n function which was inside the f function, and I will have the c here. So I'm moving the n function from the f function to the global space, and so n function is not here now. N function is not here. N function is moved from the f function to the global space. Now this n function is in the global space, but n function can also access the variable b. Why b? It can access the variable b because of the lexical scope. It was created inside the function f. So it can access the variable b, but somehow with some code modification, I moved this n function outside the function f that is in the global space. So now function n lies in the global scope, but it can access the variable b, whereas a and other variables or functions inside the global scope cannot access variable b because they are in the global scope. But since n was created inside lexically inside the function f, so n can access the function b, and n can also access function c, n can also access function a, and this is called the closure when we move the function outside its lexical scope to the global space. So this is the theory of the closure. We will see in the practical coding how it is achieved. So generally, a function cannot access the variable b if it is in the global scope. But this is a special case where the function which is in the global scope, but it can access the variable b because it was lexically created inside the function f. Since it was created inside the function f, it can access the b variable, and now it is moved to the global scope. Then also it can access the variable b, and it can also access the variable a and c, and it is now in the global scope. So this is the meaning of the closures. Now we will see practically how to write closures. So let me close this. And so I explained you the theory that since lexically it was created inside the function, but then we moved it to the outside. So now we can access it from the outside, and we can access the b variable in the global space in that new function, that is the closure function, which is moved from the function f to the global scope. So let's see that code here. So I will write down some code which will explain closure and closures. We will do different kinds of the closure, so you will be able to understand how it works. Okay, let's create a. So since I am in the script, I am in the global scope. Since I am in the global scope, I will create a function f. So this is one part of the code. We will do 3-4 different types of the code which are all related to the closures. I created a variable b. It has a value of b. I created another function, but this function I am returning. So I say return function, and here I return the variable b. Since I am and consider this function as n. So in our diagram, we were having the global scope. Inside the global scope, we have the variable a. So let's create a variable equal to maybe 1. So we have the variable a inside the global scope, and we were having the function f in the global scope, which is this one. Inside f, we have another function called as n function. Consider this as an n function, and maybe it has another variable called as c equal to maybe 2. And what I am doing, I want to push this n function inside the global scope. I want to push this function to the global scope. That is what closures are. Closures means taking the function inside a function and putting it outside that function in the global scope. So what I'm doing, I'm returning this function, and this function is returning value b, that is this one. So I'm returning this function outside it. Okay, now what I will do, for example, if I do console.log of b, what will happen? So if I do console.log of b, it's saying b is not defined. Why B is not defined? Because B is outside, B is inside the function f, and globally I won't be able to access it, the B, because B is inside this function. Now what I will do, I will create a variable called as var n, which is nothing but the function f. So I call this function f and I assign it to the n. Since function f is returning the function, so if I do console.log of n, so it is returning the function, which is nothing but the n function, this part. So this is the string format because it returns the function. It returns the function. So this is the string format of the function. Now if I run this function, okay, so if I run this function and I'll do console.log of this function, because we are running the function and it gives the value, so we have to print out that value. So it is giving the B. Now this function is in the global scope and it is giving the value of B, whereas B is only accessible inside this function. But since we move this function outside the function, from this function to the global scope by calling this way, so I'm able to console.log the value of the B which lies inside the function. And that is exactly what we see in the diagram. So let me draw the diagram again and then we will relate it again. So this is the global scope, that is this script tag. We have the function f, that is this function f, and we have this function inside the function f, that is this function fn. This is the n, this is f. And we are moving this function outside this function f into the global scope, and now n lies inside here. So n lies here, and now I can access the variable b, which is here. I can console.log that variable in the global scope. Generally, this b is not allowed in the global scope, but because this n function was lexically created inside this function, so I can access this n function outside the f function in the global scope. That is called the closures. So this is the one way of the closures which we do in one way. We will see few more ways to do the closures. So this was one of the way how to do the closures. So if I want to tell in the short, we have the global scope, we have some variables in the global scope, we have the function in the global scope, and inside this function we have another function which is lexically placed inside that function. So as per definition, this function is lexically placed inside this function, so it can access the variables inside this function. That is, it can access this b variable. So I'm returning this b variable from this function. And since I'm returning this function is now moved to the global scope using this statement. And now when I run this function, it is we are able to access the b variable in the global scope, which was not possible before. In the next example, I will not return. I will create one global variable and I will use that. So in this example, we are returning the function and we are using that. We can achieve same thing in a different way. So let's do the second way, which is like this. .html. Now I will do closures using the second way. I will create a variable called as n. I will create a function f. Now here I will create a variable b equal to b, and I will say this global variable n is equal to function, and I'll return b. So now what happens? Since this function is lexically created inside the function f, so I am able to access the return. I am able to access this variable b, and I am assigning this function to the global variable n. Since n is created in the global scope, I can access that global scope inside this function f. I assign this function to the n, and so this function is now moved to the global scope, but it can also access the b variable because it was created lexically inside the function f. So now if I do f, so it will return, it will not return anything because it is some kind of, we are not returning it kind of thing. So let's see what will happen if I run this one. No, nothing will be undefined. What will be undefined? Which variable is undefined? N is created in the global scope. It returns b. B is inside here. So if I run f, nothing will happen right now, but I have to run one more thing. So now if I run n variable as a function, because n was assigned as a function, now if I run n, I will get the b. So if I do console.log of n, so if I refresh, I will get b, because n was now is a function which returns the b. So n can be invoked using the function, and its return value is the b, and b is nothing but this b. So now with the help of this n function, I am able to access the variable b, which was created inside the function f. Initially I was not able to use the b variable because b is created inside this local scope of the function f, and because of the closures, because of the closures, it is now possible to access the b variable outside that function. Is that clear? We will do lot more on closures. This is a couple of examples on the closures, and to understand the basics of the closure, we have to do lot more examples in the closures, and it will take time. So you will be, thoroughly understand what are exactly the closure. Today we only did the real, we did the real meaning of the closure, how the closures are, what exactly are the closures, and how we create a simple closures. Let's try to create one more example of the closure. We will do a lot more other examples of the closures tomorrow and on Monday. Okay, so this is 3.html. Let me create one more style of the closure. So I will create a function f. It will take some argument, and I will create another function n, the function, and it will return argument. So it will return this argument. So if I pass 1, 2, 3, it will return 1, 2, 3. If I pass 4, 5, 6, it will return 4, 5, 6. Now I will do argument plus plus. So whatever argument I passed here, it will be added to 1. And then I will return the function n. I will return this n. Now I will create a variable in the global scope. 2 मिनट बैठ किधर बैठ हाँ चलते हाँ वॉश करते So I will create another variable called as m equal to, I will call the function f123. Now I will invoke m. Since when I call f123, it is returning this function, so I can invoke m. So when I will invoke m, maybe I can say console.log of m. So what do you think? What will be the value displayed here? So what will be the value displayed here? 124. When I run this function with 123, when I run this function with 123, it goes through this one and then it increases the number 123 to maybe 124 and then it returns n. And when it returns n, I get this function with only the argument, with the only the variable argument. And when I am invoking this function m, that is this function, the argument's new value, that is plus plus, is actually displayed here. So that means this closure which we are taking it out and it has the access to this variable, and this variable is increased to plus plus. When I invoke this, it only returns this part. It only returns this part, but it has access to this variable in the memory which was increased to 1 plus. So when I run this m1, it is actually calling this argument value which was increased to 1 plus in the memory. So that means we are able to, whatever variables is changed inside this function, and whenever we are calling this closure, it is able to get the new value of that variable. It is not taking the old value of that variable, but the new value, which is the current value, it is taking that value. So that means whenever variable is changed inside this function also, that can also be taken inside the closure, because closure has access to this variable which is in the memory. So generally close variable, this function should only be able to access whatever inside this function, but now we are able to access this function, this variable in the global scope, and if its value is changed to another variable, another value, then also we are able to access it in the global scope. That is the meaning of the closure, that it can access the variable even if its value is changed. One more example I will take, that is the last example, so that you have little bit more understanding of the closures. Okay, so I will create a function f again. Here in the global scope, I'll create a function f, and I create a variable a inside the function f. That is an array a. Let's create a variable I here, and then I will loop I equal to 0, I less than 3, I plus plus. I loop it, and then I will say a of I equal to function, and I will return I. And in the end of this function, I will return a. So a is an array. It has the 3 values from 0 to 2, 0, 1, 2, and each one is having this function which is returning the I. Now, if I call this like this, var a equal to f, and now once I say var a equal to f, that is this function is called, and this function is nothing but returning the A, which is an array, and each element of array is a function, is a closure function, which has the value of I. So now if I do console.log of A of 0, since I'm putting in 0, so I will say A of 0, and since each one is a function, so I will invoke it like a function. So I'm invoking like a function. This is the function A of 0, because we have A of 0, and we have this function invoking. So what will be the value displayed here? Get so now let's run this and see what is coming. So answer is coming 3. We were expecting it as a 0, but it is not coming as a 0. Now we have to understand it why. So this function is there, and this function has this for loop, and for loop is assigning this function to this variable AI, and A is returned. So when A is returned, the what will be the value of I when we return the A? What will be the value of I in the memory? So when I return A, let's say this function is run. When function is run, I will say I equal to 0. When I will say I equal to 0, so it will go A of 0 is a function. This is the closure function. This is the internal function which has access to this variable I. So when A of 0 will run, this is a closure function, and A here it will be 0. I will be 0. But second times it will run A of 1, this return of I will be there, I will become 1. Then third time it will run A of 2, I will become 2. Then again I plus plus will happen, then I will become 3, and it will check if I is less than 3, no, I will become 3, so it will come out of the loop. So when it will come out of the loop, I is already 3. Since I is 3, and now it is returning A. Now when we call this closure function, in the memory, what is the value of I? 3. So because it run 3 times, this closure function takes the value of I, because it's a function located inside F, but it will take the I's latest value in the memory, and the latest value of the I in the memory is 3. So if I do A of 0 function, though this is A of 0, because this is not the closure, so A of 0 will become, this I will become 0. It's correctly point to A of 0. But since this is a closure, this is a function, and it has the access to the I value, since when we return it, I's value has changed to the 3. So whenever we are calling this A of 0, whenever we are calling this function, it will return the I's latest value in the memory, that will be the 3. And if I do A of 1 and A of 2, in all 3 cases, it will return I, and I's latest value in the memory is 3. So all the time I will get 3. So every time I will get 3. Why I am getting every time 3? The reason is this is the closure. This is the closure function. This is the closure function which returns from into the global scope, and in the global scope it can access the local variable, that is I, and the I's value, when I run this function, I's latest value is 3, and that is the reason we get 3 in all the cases. So many people think that it will be 0, 1, 2, but since it is a closure and it is returned to the global scope, but it can access the I value which is the locally, and this I value has pointed to 3 because of this for loop. So n number of times we call this and it will return me 3. Did you understood why I got 3 in all the cases? I get 3 in all the cases. The reason is, again I will explain. This is the closure function which is moved to the outside this function to the global scope. Since it is moved to the global scope, it can access the local variable because it is a closure, and I's current value has become 3. So n number of times if I call this, it will access this I value, and I value is inside this function, and I value has become 3 when we complete the loop. And so every time I will be able to see 3 in this all 3 cases. Now how to fix it? How to make it 1, 0, 1, 2? Let's fix that one in the, again here. Let's create here again the function, and now I will fix that point. So to fix this one, we have to, so this is the function. Let's forget this function for now. So to fix this this problem, we have to do some changes in the code. So what we have to do like that, see, I will create, okay, let's create a self-invoking function. We will create a self-invoking function in this round bracket. I will create a self-invoking function. Since it is self-invoking function, I have to invoke it. So this is the function. This is the function. I have to invoke it. I will invoke it. And when I am invoking it, I will pass it I value. I will pass I value, and I created a self-invoking function. Since I pass I value, I need to pass here as a parameter. For example, x. So whatever I value I pass in as a function invoking, it has to go here as a parameter x. Now I will return this function. I will return this function, and now instead of putting I, because I is passed here, I will pass it x. So what I did, I took the I and I pass it to the self-invoking function. This is the self-invoking function, and it can invoke by calling the round bracket, and I can pass parameter inside it, and that parameter will go in here as x, and that x will return, and that function will return another function which will be returning the x value, which is this one. So this function is a closure, and it can access the value x here. It can access the value x here. Now I will run this one. Let's call this function f1. Let me call this function f1. Now I will run this again, all this a again. Let's see what is coming. So in the first case, I am getting 333. In the second case, I am getting 0, 1, 2. So now when I pass here, I was getting this I value from this variable, and I was able to return that I value, and it was taking the latest value of that in the memory. But now to fix that problem, I pass this I in the self-invoking function, and then self-invoking function will return this value of x, which will take its localized value of x, not the value of I, which is coming from here. So it was able to take the new value every time, because it was taking whatever parameter is passed into this function, it was taking that value and it was returning it that time. So it's not taking the value which is really I. I has changed to 3, but when I is passed here separately, then it says that I in the form of x, and so we are getting x as a different value. It's little bit in the beginning, it's little bit difficult to understand. This example I will explain you again next time to make it more clear. Just remember that right now, remember this part only, that since i's value has reached to 3, so ultimately the closure is giving me the 3 value. But here we have passed I to another function, and in each case function is the value of different value. So this is not something which is kind of global to this function. Let's say this is not a global, but this is a parent variable. This is localized to this one, and in each case it is getting a new value. It is passing a new value, so it is returning that new value into this one. So here we are not actually accessing the I, though the value of I has changed to 3, but since we are returning it with this parameter, that is the local variable, so it is saved with that variable and pass it to the AI. And that's the reason it is giving 1, 2, 3. I will try to explain this in a different way next time, so that it makes it a little more clear to you why we are getting 1, 2, 3 here and not the 3 every time in this case. So I don't want you to absorb everything in one day. Just try to see this, with this method, at least we don't get the 333 in all case, because I is something which has 3 value, but x, which is local parameter which is coming inside here, it has different value which is really assigned to AI, and then we get different value outside it. So it will be more clear when we will do little more examples on this one, and I will try to explain it in different way next time, so that you can understand it better way. So just remember that what closures are. Closure is something which is inside the local space and which is moved moved outside to the global space. And we saw some of the examples of how to do the closure. This is little bit complicated one, and I will try to explain in different way next time. Maybe that will, you will try to absorb the new method and you will understand what exactly we are doing. So this is little bit complicated and little bit difficult to understand in the beginning, but if I will explain you this part again and again, it will be easy for you to understand. So that's it for today. We will